So here's the source code behind the moving balls example that you took a look at in the previous slide. What this what this application does is it takes advantage of the JFrame's ability to use the paint method to draw these balls, draw this ball on the screen, and of course drawing a rectangle, and essentially watching that ball bounce off the sides of that rectangle. It's a fairly simple program when we think about it. Despite the complexities, it's really a fairly simple program. We have to set up a bunch of integer variables to track all of our information. The reason we're using variables is because this is going to change as the program executes. So we set an x and a y variable, an x change and a y change, old x, old y, top x, top y. We're also setting a diameter and a width and a height. The diameter will be used to determine the size of the circle or the ball, and the width and height will be used to determine the size of the container. We have an initialize method. It's going to create a new thread object and start that thread. Again, notice that our applet implements the runnable interface so we can handle threading in this applet. The paint method simply draws a rectangle at the specified location with the specified width and height, gets the current background color, sets the color to the background color, fills in the oval with the background color at the old location, changes the color to red, and draws the ball or the oval at the background color in red in the new location. But the thing is that how those locations change really depend on what happens while this is running. You'll notice that we've set the y change and the x change to 5 and 2. That means every time this loop in the runnable interface runs, we're going to move positive or negative 5 on the x-axis and positive or negative 2 on the y-axis. And so as this runs, it just keeps moving that ball from place to place, right? We get the current location as the old location. We set the current location as the old location. As long as we're greater than 1, then we set x equal to 1 and the change equal to the negative amount of change. Or we do some math and figure out how much we want to change direction x-wise. Then we figure out the diameter. And again, we're doing some math to determine the change in location. We do the same thing with the y value. We then calculate a new x and y value and we call repaint. Now what repaint does is again just calls the paint method for us, and the paint method will then redraw the screen. Then we're going to pause for a quarter of a second, actually 25 hundredths of a second, and then we're going to repeat the process all over again. And when we're done, the end result. So we've paused, we've changed, we change. Every time this thing runs, we are moving until we hit a wall. Then we're changing direction in a minor fashion. You can see there's a definite pattern here based upon how far we've decided, and we can alter that. We can say move more on the x-axis, move more on the y-axis. But you can see the pattern here. And the pattern is here because we're following the same steps in that loop every time.